8.4. So, properties of rhombuses, rhombi. Oh, you guys cannot see what I'm doing. I can see what I'm doing. Rhombi, rectangles, and squares. Before you use properties of parallelograms, now you're going to use the properties of rhombi. Rhombuses is a crazy word. Rectangles and squares. These are the set definitions that your book states. Generically, you guys have always learned that if it has 4 congruent sides, it's a square. Actually, it's a rhombus. Okay? A quadrilateral is a rectangle if and only if it has 4 right angles. Okay? And then last but not least, a quadrilateral square if and only if it is a rhombus and a rectangle. So technically, when you guys learn from geometry in 5th grade, it's actually a rhombus. Okay? And the square is a rhombus. But it's also a rectangle. You did learn that part. We just give you a disservice. Now, what's the difference between this versus 5th grade geometry? You guys need wise. You gotta understand everything before now. Okay? A rhombus is a quadrilateral if no matter what, with 4 sides, but also it has 4 congruent sides. Well, what makes it very special? If it has congruent sides, all 4 of them congruent, what do we know about opposite sides? They're congruent, right? So you have 2 pairs of opposite sides being congruent, which makes it a very special figure. It starts with a P, and you just learned about it. It's a parallelogram. What about number? The second one, rectangle. Sorry, in my head I always think of third. Second one, opposite angles are congruent. Parallelogram. They're also perpendicular, which means if all of these are perpendicular, this guy's slope has to be the same as that slope. The slope has to be the same as that slope. That's the definition of parallelogram. So a rectangle is a parallelogram. And last but not least, if it is a rectangle and a rhombus, of course, square's got to be a parallelogram. So, with this, they really need to rename this section special parallelograms, not just start off with quads. These are all parallelograms. You can get to a rhombus, a rectangle, or a square until you prove that you have a shape, a convex quadrilateral, that is a parallelogram first. So everything you did in 8.4, everything you did in 8.3 does not go away. And you can't forget those properties because they still hold true. You with me on that? So there's a lot. So if you go to your very front of your guys' notes, the calendar, we're just going to talk about the progression. We're not going to talk about anything about the inside. We're just going to talk about the progression. So what you're looking at is this wonderful thing here. Okay? So we're ignoring the words. We're going to have a new sheet, probably Monday. So, when you have a quad, you got quadrilateral first. It falls underneath 3 categories. Technically 4, because it might not fit any of those. It might be really weird. Well, depends. Quadrilateral, 4 sides. It can either be a trapezoid, a parallelogram, a kite, or quadrilateral. Okay? If it falls within these special realms, then it gets to be classified even more coolly. Because that is a quadrilateral. You like on that? Parallelogram. If we do everything here, we got parallelogram. We got this. Okay? Now you have rectangle, rhombus. If you have a rectangle, you better just prove it as a rhombus. Because what if that rectangle is a rhombus? Then you have a square. So you have a progression of proof that you have to do now. Okay? Before you get all freaked out about it, we're doing algebra proofs. We're not doing full-on out 2-column proofs and everything else. Those who are busy writing this stuff down, don't worry about it. You're getting a new sheet. We're going to change how I'm doing this form. Because I've done it different for your guys' class versus period 3, and I haven't even done it in period 4 yet. So, I'm going to change it on Monday. So, with this. Rectangle is this. Okay. Parallelograms. Opposite sides are parallel. There are parallelograms out of space. So you don't classify as any of these 3. Okay? That's why there's like 2 of them out in space. Now, if on that parallelogram all 4 sides are congruent, or consecutive sides are congruent, consecutive works as well, it's a rhombus. Everyone's done that. If the parallelogram has 4 right angles, but not all 4 sides are congruent, it's a rectangle. 4 right angles. Yeah, they're not here, but it tells you here. It's also known just telling you in words. Okay? If both of these are true, it's a square. So a square is a rectangle and a rhombus and a parallelogram and a quad. All squares are everything up above. Okay? All rectangles are not squares. All rectangles are not rhombi. But all rectangles are parallelograms. All rhombuses are parallelograms. All rhombuses or rhombi are not rectangles. They only are rectangles when they are a square. The only way that a rhombus and a rectangle are going to share the same shape or the same name or be the same is when it's a square. That's the only time. Okay? Every other time, it's going to be probably one or the other or neither. If it is one or the other, you have to disprove the other. Because if you get a rhombus, you got to disprove it being a rectangle in order to make sure it's not a square. Okay? You understand that? It's because I said the word prove, and you don't like the word prove. Trust me, we'll get there. I promise. I got one. Okay? Parallelogram is a rhombus if and only if its diagonals are perpendicular. Parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. And a parallelogram is a rectangle if and only if the diagonals are congruent. These are more things to use. What we're going to do is we're going to go jump in the math and have fun with the geometry part. Angles or 90 degree or lines from 90 degrees, or those shapes are opposite reciprocals. You flip your fraction. Okay. I know. Hey, guys and gals, just to let you know, I'm recording this for Raya. Like, she asked for it to be recorded for her. So, like, it's for your student in your class. Wait, it's recording? Yeah. Okay, now we're done. Alright, you got a rectangle. Okay, you got a rectangle ABCD. This is for any rectangle, so I just got a sketch of a rectangle. Okay, I want to know when, if at all, any, is AB congruent to CD? Is it always or sometimes? And if it is always or sometimes, when is it going to happen? Okay, so you got to remember a rectangle. A rectangle is also, it has four right angles. The diagonals are congruent. It's also a parallelogram. Opposite sides are congruent. Opposite pairs of opposite sides are congruent. So, when, if at all, is any rectangle ABCD having the opposite sides congruent? Is it always or sometimes? Raise your hand if you say always. Raise your hand if you say sometimes. Well, if you say sometimes, you have to find the time that's not true. Oh, let's just go with always. Always is supposed to work. Too bad. I don't know. Hold on, Chris. Why did you say always? Because you're the first one to shoot your hand. Because opposite angles are congruent. Also, rectangle is a parallelogram. Consecutive angles are supplementary. All this fun stuff with a rectangle, right? Also, because it has four right angles that are opposite of each other, the slopes are the same. Makes it all a parallelogram, right? So, in parallelograms, opposite sides are always congruent, right? Rectangles are always parallelograms. So, this would be always. Now, what types of rectangles can you draw? How many different rectangles do you get? Two. You have a rectangle and you have a square. So you got this picture here, and then you also would have the picture of a square. And it's always. Does not mean that it's sometimes. Well, why not? Only because I know Alex making sense stuff? Yes. But you and I have had many conversations one-on-one where I understand how you explain something where no one else gets you. That's Alex's explanation. So, going back to, I'm explaining Alex's explanation. So, we already know it's parallelogram, right? Yep. Okay. We already know opposite sides are congruent, correct? So, we know that AB is congruent to CE, BC is congruent to AE, correct? We all agree on that? Well, now consecutive sides are congruent. Which means if this is already congruent to this, and this is already congruent to this, what do we now know about all four sides? Because of the long short side are congruent. That's the long short side is now a square. Okay. So this is sometimes. That is when you have a square. Because when all the sides are congruent, it makes it into a rhombus. And a rhombus and a rectangle make a square.
Okay.
It's a picture in the middle, Venn diagram. Okay, there's a lot of math in it. Okay. Your argument is your argument is a rhombus a parallelogram or is a parallelogram a rhombus? A rhombus. Whoa. No. A rhombus does have congruent angles because it's a parallelogram. Okay. Hold up. Can I talk? Hey. The difference between a rhombus and a square is 90-degree angles. A square is a rectangle, which is 90-degree angles, and a rhombus is all four sides congruent. That is a square. You guys were taught only up until now, like literally squares all four sides are congruent. And they just happen to have 90-degree angles, right? And then also, a long time ago, you guys had diamonds that were not these squares, right? That had angles that were not 90 degrees, but we call them diamonds. They're not called diamonds, they're called rhombuses or rhombi. You with me on that for now? So you remember that's how, like, in elementary school you define to know between a square and a diamond? Because you had the cool, like, little yellow blue pieces, and then you had your squares that were usually blue. Okay. And they said diamonds and squares. Because in your guys' do you think as a little kid you remember the word rhombus unless you have a math teacher who's going to make sure that your child's the one that's the oddball out?
Actually, yeah.
Okay, so this one, yes, too. Okay, so it's like Donna when he calls her a tetra. Second round. Sorry, I didn't say it. That is a diamond. You're talking about a kite. It looks like a kite, but it's not a kite. So, Avery, Alex, here's what it works out. You're saying umbrella, okay? Umbrella is the big idea. Parallelogram. Everything underneath, all the parts connecting, is going to be your rectangles and your rhombus. This part where they connect, rectangles and rhombus.
I don't know.
Okay, so. Sure. Here's the deal. All the stems that are holding up that umbrella are rectangles and rhombuses, and where they meet on the umbrella, like stick, that's your square. Like that's how specific it is. Your stick for your umbrella is a square. It's the most specific. It has to be everything up above. I'm not making a mushroom. Avery. Yes. No.
What?
A square is everything up above. A square is everything. Parallelogram is like your mini idea. Yeah, they are each other, unless they are in one specific shape that is a square. The only time that a rectangle and a rhombus are the exact same thing, like they're the same shape, and they exist. Square is always a rhombus. Alright, so here. We're now gonna get through this lesson. You still have homework to do if I don't get to the tree. So it doesn't go away, dude. Okay, class minus special quad. This is a quadrilateral. It's got 4 sides. We now have you can't do anything until you tell me if it's a parallelogram or not. And if it's a parallelogram or not, then you get to play rectangle or not. Then you get to play everything else. So hold on. Hold on. Yeah. Class minus special quad. Quadrilateral. We start with the quadrilateral. Parallelogram. Is this a parallelogram? Yes or no? Yes. So, we have a parallelogram. Opposite angles are congruent, so therefore, we also know that opposite sides are congruent. Okay? The reason why I'm bringing in the sides is because I see ticks in there. I need to know about the ticks on the sides. Congruent tick markings on the sides, not the angles. Okay? So, the next part. Is it a rectangle and or a rhombus? Is it one or the other or both? Start first and foremost. Is it a rectangle? Why is it not a rectangle? No 90-degree angles. No. No. Don't assume. Please be quiet. So, let me talk, please. So, not a rectangle. So now square's off the table. Because it's not a rectangle. Can't say anything about a square because it's not a rectangle. Possibly, it could not be a rhombus. You gotta prove it. Oh my gosh, please let me talk. Chris, let me talk. I got you. You have a question? I know. Yeah, I know. Okay. Back here up in parallelogram. I said opposite sides are congruent, correct? 2 ticks, 1 tick. Opposite sides are congruent. I added the blue because I stated it. Now, they showed you the green. So, if we already know that this side is congruent to this side, and this side is congruent to this side, these green ticks makes the 1 tick and the 2 tick congruent, which makes all sides congruent. Which is why it's a rhombus. Next to each other. So, no, you have to explain. You have to do this. Then you write down in out. So, then that's what you would write down. Do you understand? Like if you explain it in words and you explain and you draw pictures and you color code or whatever you need to do to get me to understand what you're saying, do that on your paper. Avery.
1/6 and then 1/6 and then like some of them have like how they get the angles.
Because all this does.
Yeah, but like see how there's one there and two there. And you're talking about one there and two there.
Correct, but she's saying why aren't the angles all congruent now? I understand. I understand what you're saying. What is happening is this. You've taken, so you know how you have a square that has 90-degree angles? All we've done is we have tilted it. So one angle became an obtuse angle, one angle became an acute angle. So when you take, like you remember those, they're toys, but they were like, kind of like, what's the word, popsicle sticks that you, like, they have the corners and they make the square? I don't have any of those anymore. But you could tilt it, like it was a perfect square, and then you would tilt it and the angles would get bigger to compensate you sliding those vertices. So this probably was a square at one point. What they did is they tilted things. So they stretched and damaged. So that made these angles bigger, that's why they can't be congruent. Because if they weren't congruent, all those angles were either all big or all small, you wouldn't get this on the 360. Because these are all small. 360 is a quad. These all have to add up to 360, right? So, because it's a parallelogram, also these ones have to be 180. So if these two angles were congruent and these two angles were congruent, you would never get to 180 or this on the 360. Or you'd be too big and you would not have your legs touching. So, based on the rules and the wonderful humans who came up with geometry and everything else, it wouldn't be a shape, and it wouldn't be possible to be a shape right there if it was all congruent, either big angles or the little ones. The only time that they all can be congruent and add up to 360 is when they're all 90 degrees. And that's when you have your rectangle. Did that clarify for you? Yes. You're welcome. I figured you would. We're going to skip number 3 because we're not arguing about wonderful squares. Cool. I got 5 minutes and I've not gotten to a trig question. So, number 4, just looking at this diagram. Is that a square? How about that diagram right up there? Is that a square?
We don't know.
But right now, I'm just looking at it without doing any math, just looking at it. You know it's a square. Okay, do we know it's a square? Just looking at the picture without doing any math. Just looking at the picture, knowing 24 inches all the way across all 4 sides. Do we know that this is a square?
Yeah.
No, because you don't know that the angles are 90 degrees. You don't know. You don't know the 90 degrees yet. Now, flip side. I'm telling you, your diagonals are now congruent. Diagonals are congruent. You then get to say it's a rectangle, so then it is a square. All right. Homework. You have page 531. I only know this for like one day, so don't freak out.
Wait, so what is that?
Numbers.
Sorry.
2 through 24 even. Okay.
531.
32 through 48 even.
Oh, why did I